Hi guys, this is your Rajshekhar sir from our SAIMEDHA coaching center. In this video, we are going to discuss few more questions on transformers which are important for our competitive exams for all types of students like HPCL, KPTCL and APGENCO TSTRANSCO AP and Telangana like all aspirants. Let's see this question sir. Let's see these questions in the transformers. What they given? A single phase 50 Hz 200 by 500 volts transformer, high voltage side. They given high voltage side. Remember that point. Excitation with the 38 edges. They given actually on the high voltage side excited with 38 edges. To maintain same flux density, the excitation voltage should be. They given frequency. Now they are asking the voltage. What you can say that in order to maintain same flux density, the V by F ratio should be constant. Initially the V 500, the F 50 edges, because they given high voltage side. We have to consider on high voltage side. What about the voltage? Now they are asking if the frequency is 38 edges. You know, this is very simple answer. V is equals to 380 volts. If the V is equal to 380 volts, then the V by F constant. If the V by F constant, what sir? The magnetizing current also constant, flux density also constant. And here you have to remember that in order to maintain same flux density, in order to maintain same magnetizing current, in order to maintain same magnetizing characteristics, the V by F ratio should be constant. When the voltage decreases, the frequency also has to be reduced. If the voltage increases, the frequency also has to be increased. For example, when the frequency reduced from 50 Hz to 38 Hz, then the voltage has to be reduced from 500 volts to 380 volts. If the voltage is reduced by 10%, we need to reduce the frequency also with same factor. If the voltage increased by 18%, we need to increase the frequency also with the same percent. Then the V by F ratio will be constant. You know already. Right, sir? Let's go for next question. In a single phase transformer, flux density given as, the maximum flux density given as 1.8 Tesla. Area of the core given as 1.2 meter square. If the flux density reduced to 0.9 in a transformer, if the flux density reduces, ultimately the area of the core will be increases. You know, generally the transformer core made up of CRGO steel. Of course, we have a amorphous steel also. In CRGO steel, the flux density is very high, greater than 1.8. But in amorphous steel, the flux density is very less than 1.6 even. So compared to these two, generally the CRGO steel used for power transformers, which is PTR. The amorphous steel cores are used for distribution transformers, which is DTRs. For same rating, in power transformers, flux density is very high, that's why its area is less. In distribution transformer, the flux density is less, that's why the core area will be more. This is concept we already discussed. And here always when the flux is constant, flux nothing but B maximum into area should be constant. Nothing but B1 into A1 should be equals to B2 into A2. What is B1 here? B1 is a 1.8. A1 is a 1.2. B2 is a 0.9. Now they are asking A2. So what is the answer, sir? 9 ones are 9 twos are 24 by 10. 2.4 meter square. 2.4 meter square. Of course, if you have a good grip on the problems, when the flux density doubled, the area of the core will be halved. That's it, very simple. If the flux density halved, the core area will be doubled. That's it. Yes or no, guys? Next question. In a single phase 50 Hz 200 by 400 volts transformer, if the primary number of turns and flux doubled but frequency halved, then the new EMF, what they given, EMF directly proportional to flux, frequency, number of turns. What they given in the question, if the number of turns and flux doubled and number of turns doubled, but the frequency halved, that is 2 times of the phi m into f into n, therefore EMF doubled. Here the EMF increased by 2 times, or simply EMF doubled. Very simple question, sir. Let's go for next question. In a single phase 50 Hz transformer, if voltage and frequency both are doubled, then the maximum flux density. Generally, the maximum flux density is V by F. When the voltage and frequency both are doubled, that is 2V and 2F. 2 gets cancelled. Again, we can have same V by F. When the V by F is constant, ultimately flux density is constant, magnetizing current also constant. A very simple question, sir. Next question. A single phase 50 Hz 20 kVA transformer connected to 200 edge supply. Then the kVA rating will be. This is also very simple. The kVA rating is nothing but EMF into current, right? Where EMF is directly proportional to frequency, where kVA rating is directly proportional to EMF. Simply we can say the kVA rating is directly proportional to frequency. When the frequency increases, ultimately the kVA rating also increases. Here the frequency increased by 4 times. Here the frequency increased by 4 times. When the frequency increased by 4 times, ultimately the kVA rating also will be increased by 4 times. What is the new kVA? The new kVA of the transformer is 4 times of the 20 kVA, which is equals to 80 kVA. We have 2 conditions. One is that if the frequency increases, kVA rating also increases. Actually, we need to mention that the size of the transformer will be constant. And the second point, if the frequency increases, the size of the transformers will reduces when the kVA rating is constant. We have these 2 factors, these 2 points you should remember. Right, next question. What is the answer for this question, guys? A single phase 50 Hz transformer having 200 turns and primary EMF maximum, what they given, E maximum. In the primary, the maximum EMF developed is 31400 volts. Then what is the maximum flux of the transformer? Very simple, sir. What they given, E maximum. What is the formula for E maximum? Do you know? Yes? I hope you have an idea. 6.28 into phi m into f into n. We discussed in the transformer EMF equation, where the E maximum is equals to 31400. This is the value of 628 by 100. Now they are asking phi m with frequency of 50 Hz and number of turns given as 200. These two zeros cancel. 50 2s are 100, 50 2s are 100 cancel. 314 1s are 314 2s are. So phi m is equals to 1 by 2, which is equals to 0.5 Webers of flux will be there. These are a few simple questions, sir. Very simple questions. Let's go for next question. Yes, can you calculate and give the answer for this question? Can you calculate and give me the answer for this question? Single phase 50 Hz transformer primary RMS voltage given as 888 and maximum flux given as 20 milliweber. Then the number of turns in the transformer primary. So what we can say, E is equals to 4.44 into 5m into F into N. E they given as triple height is equals to 444 by 100 into 5m they given as 20 milliwebers. Frequency of course 50. Now they are asking number of tons. Now they are asking number of tons. 1, 2 cancel. 2 5s are 10 cancel. 444 ones, 444 twos are. So the number of tons is equals to 200. Very simple question, sir. Okay, next. Let's see this question. Single phase transformer transformation ratio they given as 1/2. Primary having 200 tons. Primary having 200 tons. EMF per turn in secondary. They given EMF per turn in secondary. Nothing by E2 by N2 they given. E2 by N2 is equals to 2 volts. Now what they asked? E1 they are asking. E2 they are asking. First E2, calculate the E2. E2 is equals to 2N2. Oh sorry, we need N2 again. What is N2? They are asking N2 also. Very simple sir, K is equals to N2 by N1. N2 by N1. 2 1s are 2 50s are. N2 by N1. So N2 is equals to 50. K they given as 1:2, transformation ratio 1/2. N2 we don't know. N1 we know that. Sorry sir, what is the N1 value they given? 200, right? N1 is a 200, right? So 2 1s are 2 100s are. So N2 is equals to 100 tons. When N2 is 100 tons, E2 is equals to 2 times of 100, 2 times of 100, which is equals to 200 volts. E2 completed, N2 completed. What is EMF per turn in the primary? EMF per turn in the primary exactly equals to EMF per turn in the secondary. Both are equal. So now can you tell me what is E1? E1 is equals to 2N1. That is 2 times of N1 is a 200. 2 times of 200, that is equals to 400 of course. E1 is equals to 400. E1 is equals to 400. EMF per turn in the primary also 2 volts because transformer is a constant EMF per turn. If the 300 kVA transformer, then I1. I1 is a kVA rating of transformer divided by E1. What is the kVA rating? 300 kilo divided by, what is E1? E1 is a 400. E1 is a 400. How you can say? These are gets cancelled. 3 by 4 times into 1000. 3 by 4 into 1000. Kilo. Kilo nothing but 1000. So the answer is 750 amperes is my I1. 750 amperes is my I1. What is I2? I2 also as usual sir. kVA by E2. kVA by E2. What is kVA? 300 kilo by E2. What is E2 sir? E2 is a 200. 200 ones, 200 5s are. So the I2 is equals to 1500 amperes. 1500 amperes. So like that you can have answers for these series of questions. Simple questions only sir.